Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we'll solve another question from Leetcode itself. So let's get started. Yes. So today we have a question tagged at easy. So yeah. So first read the problem statements. We will understand the problem statements. Then we will go to the our intuitions building, and post that we will jump on the solution part. So the question stated sum of all subset XOR total. Sum of all subset XOR totals. So what they have given the XOR total of an array is defined as the bitwise XOR of all its elements. Bitwise XOR of all its elements, or 0 if the array is empty. Very straightforward. For example, the XOR total of array 256, the XOR total of array 256 is 2 XOR 5 XOR 6. So that is going to be equivalent to 1. Now, given an array nums, they have given us an array nums, return the sum of all XOR totals for every subset. XOR totals of every subsets of nums. Note, the subset with the same elements should be counted multiple times. A subset with same elements, if our nums has repeated elements, then they can be counted as multiple times. So that is allowed. I guess you guys are already know what is actually the subset. An array A is a subset of array B if A can be obtained from B by deleting some possibly 0 elements from B. So if you guys don't know what is actually the subset, then I can give you a quick gist of subset. So yeah, so okay, so on subset it is something like if you have an array elements. Oh shit. So if we have an array elements like, so let's suppose that is our nums, and if we have array elements like 1, let me delete these things. Let's suppose we have 1, neglect these things, this process, or let's suppose nums 1, nums 2, nums 3, nums 4. So if we have this elements or in our nums array, so subset can be, you can choose any of them. That should not be contiguous portions, that should not be contiguous. You can choose this, you can skip this, you can choose this, you can choose this. So your nums 1, nums 3 and nums 4, so these are a part of your subset. This can be a part of your subset. So that is actually subset. So if it is a sub array, then if you are choosing from here to here, then that is a contiguous portions. You can't skip. Let's suppose if you want to skip nums 2 and if you want to get nums 3, that is not allowed if it is a sub array. But for our case, it is a subset. So if it is a subset, then you can do like for every elements you can either take or you can't take. So you have two options: take, not take, take, not take. Yeah. So like this way you can form your subset, and for every subset, when you are forming a subset, when you have done with preparing your subset, what you have to do. So let's suppose your subset is this, and then you do a XOR among them. You do a XOR. So let's suppose nums 1 XOR nums 3 XOR nums 4, and you save it as a variable, let's suppose A. And like this way let's suppose on next go you choose nums 2, nums 3 and didn't choose nums 4. Scrolling, man. And you didn't choose nums 4 and nums 1, right? So in that case let's suppose you formed another subset with choosing nums 2 and nums 3. So like this way, all the subsets we can generate from the given nums. We have to do XOR of all of them, all of them. What is the subset we are able to generate? And after that, what all the values you are getting. Let's suppose you have another subsets with nums 1 only, and let's suppose another subset with no one, empty subset. So for empty subset, no XOR, that is 0. And finally, what you have to do, you have to return the results of all the subsets you are able to generate. The sum of them, A plus B plus C plus D, whatever dot whatever the number of subsets you are able to generate, you have to do, you give me the XOR of them. You have to give me the XOR of them, right? So the question is as simple as that, guys. So that is actually what they are looking for. So I am assuming that you guys are already aware how we can generate all the subsets of a number. So basically to generate of a subset of a number, by this only you guys got the intuition. So if we have numbers like X, Y, Z, P, Q, R, S. So if that is the array is given to you, so for every elements you have two options: either take or not take. Either take or not take. So like this way, for every elements you have take or not take, Like this way you will iterate to your iterate to your nums, and when you are like out of bound, when your index is out of bound, then on that times whatever the calculations you have done, you can return. So that's actually the very basic problems on the recursions, where you have the opportunity to take or not take like this. So you can generate all of your subset. How and the point to note, like if you have n numbers in that is of len of nums, then how many subset you can generate? You can generate 2 to the power n subset, 2 to the power n subset. I think that is very standard mathematics things. Like for every elements you have two options. For every elements 2 into 2 into 2 into take not take like this way, you have n options still. So 2 into 2 into 2 is going to be multiplied is n times. So that is like 2 raised to the power n. So for every nums of size n, you have 2 raised to the power n possibility. 2 raised to the power n subset is going to be generated. Yeah, and now when you have generated your subset, when you are basically taking the decisions for a particular number, when you are taking the decisions of putting it to a considering it to the subset you are generating, then you can do a XOR. And if you are not considering, then don't do anything. The question is as simple as that, guys. And when you have done with the iterations till end, then on that times you can return that. And for every possible things, for every possible index, when you make a recursion call, you can add them out. Like this way you should be able to form your answer. So let me just quickly write the pseudocode for this, so that you guys get a better gist what I just explained. So we have an helper functions, and before that, like we should take a note on our constant. What is the constant side? So it is, they have explained the same things what I have just explained on the OneNote. If you want, you can go through this. So you can see that nums length is very small. So that is the point. So so that is the like major hint. So if you have your constant is very small, very tiny limit, then definitely think about just do a standard recursion. But if it is going to be a more, then you have to think, can you make a like DP tables kind of things to basically store what is pre-computed. Can you store some things on the DP tables or some tables type of things? But here the constant is very under. So what is the maximum we can grow? We know for every elements we have options take and non-take, and our n can be grow as big of 12. So 2 raised to the power 12, it is very under of 10 raised to the power 8. So we are very good state. So that's the hint. So they basically allowing you to use standard recursion, and that's the reason also the question is stacked as an easy difficulty level. Yeah, and I am also feel so, like it is very basic recursion, like take not take case only they have asked for. Yeah, so now like just quickly write our pseudocode. What actually we have to do. We initially take an index and the total. Like till now, what is the total we have? And now for every index, what is the base case for our case? We just discussed if at any particular point it is going to be like end of the like out of boundary elements on that case, then what is the total you have at? Just return your total. What you have at. But if it is under boundary, then you have two options. What are the two options? You can either take. So if you are going to take, then what is your next functions call? Give me 1 minute, guys. I think there is some problems that actually creating the issue on my new device. So let's suppose we have things like we are taking. So let's consider the case of take. So if we are taking, we for sure go to the index plus 1. That's the for sure we are going. Index plus 1. What else? Sorry. Go from here, we can go. Yes. No, I think there is some little bit noise. Yes. So we for sure can go to plus 1 index. And if we are taking then what is the extra? What is our total? How our total is going to be updated? Our total should be nums of index XOR with, our total should be XOR with nums of index, right? Agree. Exactly. But there can be another case. If we are not taking, then what is the case? Can you guys tell me? We are obviously going to index plus 1. That's the for sure. We are going to index plus 1, and our total should be unaltered, our total should be unaltered, our total should be as it is our total. And what we have to do, like this way, when we are hitting our base case, we have the XOR, we have the total XOR, we have the total XOR ready, because when we are taking, we do the XOR here, we are doing the XOR here, we are doing the XOR here, so we have the, so we here, from here we are doing the XOR, so we have the total of that subset, the subset we are considering, we have the ready with the XOR we are carrying. And so that is for take case. And for non-take case also, we have the totals already. And when we are going to out of index, so this totals is going to be returned from the very last function call, from the very last function. It is very basic, guys. I am assuming you guys have the like strong grip on the recursions. Otherwise, mostly you are not going to relate the things. But if you are not like done the very basic recursions and like recursion tree diagrams by your own and not able to understand at any particular point, please do comments. I will be happy to make a separate video how actually the recursion tree is going to be generated when we are making the recursion call. But for this question perspective, I am assuming you guys know the basic recursion. That is a very basic recursion which we are discussing here. That is very basic things on the recursion. And like this way, we are able to have the total XOR of the subset we are considering, and now what they have asked for, they basically need the add, right? They basically need the summations of that. So what they are basically looking for, return the sum of all the XOR totals. We have the XOR totals ready of all the subsets. Now what we have to do, can you guys tell me? We have to do a plus of these two, that is of our take case, and that is of our non-take case, and we have to do the XOR of them. And finally we can return what is the add variables. We are doing the additions of both, we can return that. And our functions call, like what is the initial functions call, we will start from 0, and what is the total for initial go, we have 0. And finally we can return these things only to the actual functions call they have provided. Yeah guys, the question is as simple as that. So I will just quickly iterate. I have written exactly same things which I just discussed on the OneNote. So n is the length of the nums, then we have initialized with index and total. If our at any particular point index is going to be at last out of boundary of the nums, then we returning our total. And for add we have two, that is the non-take case, we are just going to next index, and the total, whatever the total we have at, passing as it is, and that is a take case. So we are obviously going to the next index, but here our total is going to be XORed with nums of index, and finally we are returning order, and we are making the functions call at 0,0. So that's all about this particular question solutions, guys. And now quickly discuss the time complexity. I guess you guys have already done your own analysis. Can you guys tell me? We are doing standard recursions of take not take case, so it is obviously going taking a time of 2 raised to the power n. And on space perspective, do you feel guys we are using any space altogether? No, but if you consider the recursion stack space, it can go like index can go to as big as recursion stack trace can go as big as big of n size, because our index can go to, like if it is index of n, then only the functions is going to be hit its base case and we are returning. So our stack trace can go as big of n. So if you considering this, then you can consider, but if you don't want to consider, then you can like tell. But I am basically very eager to, if I am going to take the interview, then I want like you should be pinpoint what actually the space for this particular code you have written. If I am, maybe you can tell that is the recursion auxiliary space complexity, but please explicitly tell like on function perspective, the code we have written, there is no space altogether we have defined and using on particular question, but there is a background there altogether code executions. It is going to be make a big of in stack trace space of if you are using Java, then JVM is going to be allow this big of in space complexity on its heap memory. So please explicitly tell these things, that is going to be make you as different from the other candidates. Please explicitly tell these things for every variables you have declared, every iterations you are doing, please explicitly mentions the time complexity. But yeah, on big of terms you can tell it is on n log n or log n or big of n square, you can tell these things, but for line by line mathematical terms, just explain these things. That is going to be make yourself too different from the other candidates. So please do that. So that's it guys, that's it for this particular question solutions. And if you are able to understand till this point, I know what you have to do, and I guess you guys also have to be aware, like please do subscribe to our channel and please turn on the notifications so that when we are going to live with our next video. So bye guys, let's meet tomorrow with another beautiful question. Bye bye.